So for the last couple days, that law of sines is what we do when we have a pair of an angle paired with a side. And so we'll just see that, just to review so we have in our notes officially. Okay, the law of sines is used with an angle side pairing. So far, if you didn't have that, you couldn't solve an oblique triangle. So we need a second law to help us out for the times where we don't have an angle or side pairing. There is a law of tangents too, but we're not going to learn it in this class. And so we have the law of cosines. And this is used with no angle side pairing. So for example, maybe all you have is side, side, side. You have 3 sides. Or maybe you have SAS, but you don't have the right pair. So I'm just going to teach you the law of cosines, and then we're going to practice it with a couple situations. So here's how the law of cosines goes. It goes like this. Leave yourself a little bit of a space. We're going to put a box around it. It goes a squared plus b squared minus c squared. That's the beginning. So it kind of looks like it starts like the Pythagorean theorem, except it doesn't have a right angle. And so that's why we have to have the subtraction of the hypotenuse. So it's a squared plus b squared minus c squared divided by two ab. Equal to, now we have to have cosine in here somewhere. It's called the law of cosines for a reason. And so this is where cosine comes into play. And we need cosine of one of the angles, and it's cosine of angle C. I want you to notice that the cosine of angle C, we pick angle C because we subtracted little c squared. There's a direct relationship between these two things right here. That the angle that is in the cosine has to match the subtraction that you did of the side that you paired it with. Okay, so what I'm saying is we could switch the order of the numerator. We could have b squared plus c squared minus a squared. And if we switched the order of the numerator, then what gets switched over here is the cosine of a different capital letter. So what capital letter would that be now? It would be A. The denominator has to get switched also. Notice that these match for 2, the a and the b match what was the a squared and the b squared. And so this denominator would be 2bc, because you were doing the b squared and the c squared first, and then the a squared was the subtraction, so you could do cosine of a. So there is one other order that you could put that in. Does anybody want to try it? What's left that we haven't done? Okay, anyone want to try it? Okay, a squared plus c squared, and we need the subtraction to be b squared this time, which means the cosine would be capital B, and what would the denominator be? Yes. Okay, that's the law of cosines. It comes in 3 versions. Kind of spells a word, right? C-A-B, cab. Okay, but there are 3 versions of the law of cosines. And you just use the one for the angle that you have. So if you have angle A, then you're going to use the version that has angle A in it. If you have angle B, we'll use the version that has angle B. All right, So let's practice this. Again, you use this when you don't have a possible pair. So let's say that the problem you're given looks like this. So I'm going to set it up like we have been. And I'm going to say that we are given the three parts that are the following: 14, 19, and 8. So we are not given a pair of any kind. Therefore, we need to use the law of cosines. It's really your choice. Any one of the laws will work. You just decide which angle you want to find first. So let's just go with the first law that we had. The first law was a squared plus b squared minus c squared, which means that the cosine would have been of angle C, and the denominator would be 2ab. It really doesn't matter which one you choose here. I'm going to choose just because I did that one first. And so we put in 14 squared for A, 19 squared for B, 8 squared for C. Over 2 times 14 times 19, and that would be equal to the cosine of angle C. What am I trying to find? What is the variable? What am I trying to solve for? What am I trying to get rid of? Go ahead, Katie. Which C? Okay, angle C. And so if I want to find angle C, what do I need to do to both sides? Inverse. Okay, when you do an inverse, you need to remember parentheses. So you've got to include parentheses around the 14 squared plus the 19 squared minus the 8 squared. You also need parentheses still around the denominator. It's just one of those things the calculator needs. And you need big old parentheses around the whole thing so that you figure out what angle C is. All right, that takes a little practice. In other words, when you type cosine inverse, you need a double parentheses at the beginning. You need the parentheses that the calculator puts in automatically, and then you need another parenthesis that is going to go in before the 14 squared. So let me show you what that looks like. Could you get your calculators out, because it really is important for you to practice this. The correct way, you might know how to do the math, but you might not know how to type it into your calculator, and then you get the answer wrong. So I want you to make sure you know how to do both. All right, so your mode should still be degree. When you do inverse cosine, it's going to automatically put a parenthesis there for you. You need to include a second parenthesis to start that out. This will start the numerator. So the numerator would be 14 squared plus your 19 squared minus your 8 squared. When your numerator is done, you can close that parenthesis with a single, and then divide, and then introduce your denominator, which will also need a set of parentheses. So that would be 2 times 14 times 19. Then you need a double parentheses to close the problem. You close the denominator with one set of parentheses. You close the problem with a second set of parentheses. And the calculator will even make it a little bit larger so you can tell that you've reached the end. And then you hit enter. And you get 22.075, and those are the degrees for C. So you can put that into your notes. All right. Now we're going to repeat the process. We just do it with a different corner, with a different cosine. And again, the order doesn't matter. Let's do A. Okay, let's do cosine A. All right, if I'm going to do cosine A, then that means I set this up as b squared plus c squared minus a squared. Then I can do cosine A, and the denominator would be 2bc. So then you're going to switch the order around of things. So it would be 19 squared plus 8 squared minus 14 squared over 2 times 19 times 8. That equals to cosine A. And you apply the inverse cosine with an extra set of parentheses around that. So you can type that in. If you forget a parenthesis or you type the order of the problem wrong, your calculator will usually tell you error to tell you that you've done something incorrect. Okay, Michael, I saw you working on it. What did you get?
41.124.
Yeah, that's what I got also. All right, so A is now 41.124. Now you do not need to do it a third time. Why not? Yeah, you can just use 180 now to find the third one. And so you can subtract 180 minus 22,075 and 41,124, which gives me 116.801 as the degrees. And you should just double check and make sure that adds up to 180, and then you've got it. Now you might be wondering, did I have to do the law of cosines twice? After we finished the law of cosines the first time, what did we have here? We had a pair. So could you switch back and use the law of cosines? And so technically the answer is yes, but you would need more decimals for accuracy if that was going to be the case. Because when you switch laws in the middle of a problem, once you've already rounded 22.075, you will get an answer for the law of sines that is off as well. And so I wouldn't recommend switching laws in the middle. You can, but if you do want to switch laws, then get yourself more decimals than just 3. Go out to like 5 or 6 decimals. I would just recommend, if you're in the law of cosines for the problem, stick with the law of cosines and do the law of cosines twice. That would be my own recommendation. Just know the danger of switching laws is a loss of accuracy. Okay, let's try one more, and then you'll have a little bit of time to start some of the problems on your own for homework, or finish up the homework from last night if you were still making corrections. So tonight's homework will be pretty much no word problems, just practicing. We'll save our word problems for the next day. Okay, all right, so we've got 115 and 15 for side B and 10. All right, there's our example. Clearly no pair, and there's no way to get a pair. So we're going to have to use the law. Now the law that is determined for us, we want to use the version of the law that uses cosine A, because it's the only one that we have. Last time I didn't have any angles to start with, so it didn't matter what law I started with. This time I do have an angle, and so I have to start with the law that has cosine A. So that means I'm going to start with b squared plus c squared minus a squared over 2bc equals cos A. That's the version I'm starting with. All right, so we are going to put in, so I have everything I need but what? What's the only number I don't have? Which A? Little a. Okay, so I've got everything else. So 15 squared plus 10 squared minus a squared, which is the one I don't have, over 2bc, which is 2 times 15 times 10, and then cos of 115. This is a different kind of problem, because the thing I want to get alone is in a different place. I don't use an inverse this time, because what I want to get alone is over by the subtraction. So this is actually a cross multiplication problem. We drop a 1, and we cross multiply. 2 times 15 times 10 is going to cross multiply to cos 115. And then 15 times 10 minus a squared, 15 squared plus 10 squared minus a squared is going to cross multiply to 1. So I end up with 15 squared plus 10 squared minus a squared equals parentheses 2 times 15 times 10 cross multiplied to cos 115. Don't worry about using a calculator to type in those numbers, just leave it. Just focus on getting a squared by itself. So what do I need to do? How do I get my a squared? Like by a subtraction, how do I get it alone? Basic math, what do I do to both sides? What do we want to get rid of? We need a squared alone. What do we need to get rid of? Say that again? Not divide. This is an addition, subtraction problem. Okay, I could and I can. Okay, I'm gonna go with Connor. I'm gonna subtract 15 squared, and I'm gonna subtract 10 squared, and I'm gonna do it on both sides. That'll leave me with negative a squared equals parentheses 2, 15, 10, cos 115, subtract 15 squared, subtract 10 squared. Okay. Now what do I do to get a squared by itself? Divide by negative 1. Okay, when I do that, I'm going to have a negative in front. Let me change colors here. A negative in front of here, and these two are both going to be positive. And then what's the last thing I got to do to get a by itself? Square root. Okay, so then we are going to square root. So let me get rid of the squared, and I'm going to put a big square root over all of that. Just trust your calculator to do it right. As long as you type it in right, your calculator will do it right. Don't round in the middle of a problem. Okay, don't figure out what cos 115 is and then round it and then try and square root. Just go ahead and trust your calculator. As long as you type each piece in order, you'll get it right. So let's practice that again. Okay, if you type it wrong, you'll get error. So square root, negative, parentheses, 2 times 15 times 10, parentheses, cosine 115, parentheses, plus 15 squared plus 10 squared. Okay, trust your calculator to do the hard work for you as long as you're careful about typing that in the way you want. All right, here we go. Did you get it right, Katie?
No, but it's okay. I use it.
Okay, so yeah, that's going to matter. Okay, the calculator doesn't know what you mean. It only knows what you typed in. Okay, it doesn't know that you meant to do this. All right, so again, it's going to come with practicing. So 21.255. Okay, let's go back here. Got 21.255. You're going to do the law of cosines again. You can either do the law of cosines for angle B, or you can do the law of cosines for angle C. It doesn't matter. Or you can go back to the law of sines, but if you do, you go back to the law of sines, you're going to need more decimals, and so you'd have to add 2, 4, 5, 9 on there if you're going to go back. So it's up to you what you want to do. I'm going to do the law of cosines again, and I'm going to do it with angle B. And so if I'm going to do angle B, that means I need to do a squared plus c squared minus b squared over 2ac, and that will equal cosine angle B. So pretty much you're going to need the law of cosines twice for every problem. So this would be 21.255 squared plus 10 squared minus 15 squared, all over parentheses 2 times 21.255 times 10 equals cos B. And this time what I need to get alone is on the cosine side. So I don't need to cross multiply, I just need the inverse. And so I'll cross this out and I'll put the inverse over here. But again, what the calculator needs from you is large parentheses around the whole thing and a smaller set of parentheses around each numerator and denominator. So then again, it just becomes the mastery that you have over your calculator. So we'll come back and we'll type in, all right, inverse cosine. We'll start a second set of parentheses, 21.255 squared plus 10 squared minus 15 squared. Close the parentheses that indicate the numerator and start new parentheses for the denominator. 2 times 21.255 times 10. Close the denominator, close the problem. See, even I typed something in. Oh, see, I did plus 10 instead of times 10 there. All right. So this tells me that B as an angle is 39.763 degrees. And so now we've got 39.763. Okay, so once you've done the law of cosines twice, then you can use 180 degrees to figure out your angle C, which works out to be 25.237. So 2 laws of cosine, and then a law of 180 degrees. Just like you did law of sines, you did 2 laws of sine and 180 degrees also. You'll do 2 laws of cosine and then 180 degrees to find the rest.